Right. Still see some people rolling in here, but we are recording, so let's just go ahead and get started. Hello everybody. My name is Jamie Dennis. I'll be your host today, but you're not here to see me. You are here to see an amazing presentation on tracking wildland fire progression with NASA's Earth science data and open source tools. This is going to be a really great webinar. I'm super excited myself. And with us today, we have Anthony Boyd. And Anthony is a product manager with Development Seed. He leads the team that developed the Fire Event Explorer, as well as other open source tools to improve access to NASA's Earth science data. And along with Anthony is Zeb Becker. Zeb is a research software engineer for NASA's Wildfire Tracking Lab. His work focuses on improving the methods used to detect, track, and study wildland fires based on satellite data. And with that, I'm just going to go right ahead and turn it over to Anthony.
All right, appreciate it, Jamie. Hello, everyone. I'm going to go ahead and share my screen here. So give me a moment. Okay, let's dive right in. So our first slide here is just the bios that you just heard. And don't worry about the contact information. We'll share this at the end of the webinar, but we're super excited to be here today to talk about this tool that we built and the amazing data behind it. So first we will talk through the tool that we've built that we've been calling the Fire Event Explorer. And this shows fire progression data over time. And then Zeb will talk us through the data and the methodology behind it. And you all can dive deep into any questions you have about the data. And then I want to talk a little bit about the project context, but really the open source software that powers this tool and a lot of the tooling that we've been building with NASA to show their Earth science data. And then we will be sure to leave some time at the end for Q&A. So throughout the presentation, we will have a few different moments to pause and answer questions. So anytime a question comes up, please throw it into the Q&A. Try to throw it in the Q&A as opposed to the chat. That way it's easier for us to track. But we'll take breaks after each of these sections to answer any questions that you have. So with that, let's jump right into the demo because I think that's part of what we're all here to see. We recorded a few videos here, so I'm just going to go ahead and hit play and let them run. And like I said, jot down any questions that you have and we'll try to get them answered at the end of the demo. And if you do experience any troubles with audio, throw that into the chat as well and we can get it resolved. So right now we're looking at the Fire Event Explorer, which you can see up here is underneath NASA's Earth Data Beta dashboard. And right now I'm looking at all fire geometries for wildfires within the last month of today, September 9th. I can change this date or this time range if I'd like. Maybe I want to see all the fires of the last 6 months, and you see quite a few more fires that were active earlier in the year came onto the screen. You could also filter this down if I just wanted to look at maybe large fires or maybe fires that lasted for quite some time. But if I go ahead and hide these filters again, then I'm going to zoom into one of these areas. I'll go into this Arizona, Utah area. And I can see up here in the top right that I have a few different layers available. So the first one is this fire perimeters layer, and this just shows a simplified geometry of the most recently detected fire perimeter. And if I go ahead and hide that, I'll turn on the fire detections layer to show you another example of information. This is more of a hotspot data layer so that I can see, what hotspots are detected for each of these fires. And then I can also see this active fire fence layer, which takes quite a bit longer to load because what it's doing is actually going and finding different perimeter layers for each time step for each of these fires, which can be quite a lot of data. But you can start to see that I have a few different options available to me. So I'll jump back into this more standard fire perimeters data layer here. And if I zoom out to the rest of the content, you can also see that whereas before I was just looking at continental US, This actually covers quite a bit of North America. It stretches all the way into Canada and Alaska, and even down a little bit into Mexico. So we did get to see quite a bit of the fire activity in Canada earlier in the year. But for now, I'm actually going to zoom in to one of these fires down here in Arizona, because it's kind of a nice size with enough variation to show the capabilities of a tool like this. If I click on the fire, then I'll zoom into this fire details view. Sometimes this takes quite a bit to load, just because we are pulling a lot of information. Because what's happening now is I actually reached back out to an OGC API to gather every time step of fire perimeter data for this fire. And so we have time steps every 12 hours, twice a day. You can see here in this middle panel here that if I wanted to, I could change this timeline view to maybe be about when the most growth is happening for these fires. You can see right here in the middle, the fire is growing rather quickly. But we'll stick here on this default fire area timeline view. And if I click play, then you'll actually start to see these fire perimeters animate. And I can change the speed if I want this to move a little quicker, which is helpful for some of these longer fires. And I can see it grow over time, which is a pretty cool animation that we're able to create. I'm going to go ahead and pause that, maybe start it back from the beginning. And the next thing that we have here is I can prepare a video. Now I can prepare either a GIF or just a regular video. But the first thing you'll notice is I jumped right into a 3D view. So we're able to overlay this fire progression information on top of a 3D base map. Now again, my options are either a GIF or just a web map general video format. I'm going to go ahead with a GIF, and I'm going to choose 3x speed just to zoom through this animation here quickly. I'm going to center it on the map here, right about there, and hit start recording. And so you'll see it's a very similar animation, but it's actually recording a video right now. It's not going to record my sound, but you'll get a GIF at the end of it. I'll hit stop recording because that's most of the fire growth. And right now it's actually generating a GIF, and it's going to download it directly into my browser. Okay, one more video here because I hit my 5-minute time limit for my free Loom account. Great, now just finished downloading, so I'm going to go ahead and restart the timeline here, and we'll go back to our 2D view just to have a more simplified view of things. The next thing I want to highlight is this wind direction layer. You can see immediately we see these wind vectors overlaid on top of our fire progression information, and it's animated. So what this is actually doing is it's reaching out directly to NOAA's HRRR dataset, and which is in a GRIB2 format, all cloud hosted behind an API. And it's able to turn that data into these wind vectors that we can see animated on the map. If the animation is a little much for your computer for whatever reason, you can always turn it off and just get these static arrows, which will have the same effect. But if I go ahead and hit play, and I'll go to 2x so we can really see this, you can see that the direction and intensity of these layers will change over time, which is a really interesting data point to see overlaid on top of this fire progression data. If I hit pause, I can switch right here, which then we can see it combined with the 3D information. And if you were doing this while you were generating a GIF, you would get basically this view. You would see the static arrows overlaid on top of the map. So you can also export this wind layer through your GIF if you would like. But you can really see how interesting and powerful this animation is, especially as we start to zoom out a little bit. We end up with a pretty cool visual at this more continental level. This data from NOAA is restricted to the continental US, but it does set a pattern for how we can take GRIB2 data, weather data, and integrate it with geospatial or earth science visualization tools like this, and then overlay it on top of other information. Great, so I'm going to turn those off for now, but the next thing I want to highlight in this details panel, which has a bunch of different statistics about the fire that we're looking at, is this download button. Something else that we added recently to this details panel is that you can take any of the layers that we've been talking about so far and export them either as GeoJSON or as CSV. And this will just download as a zip file immediately into your browser, just like any other file. And then that makes it really easy to pull into your GIS environment or share with a colleague. Another way to share things with a colleague here is to actually just copy and paste the URL, which will bring your colleague or friend directly to this same view, to the same fire, and they can explore it for themselves. So if you find anything interesting in the app, there's a few different ways that you can really quickly share whatever you've found. But for now, I'm going to jump back out then to this larger view here. All right, so that's the Fire Event Explorer. If you have any questions on that, definitely drop them in the Q&A. You might have noticed during that time that I think I mentioned the Veda project, and you'll hear us talk about that. And I'll go into details on what that project is, but that's essentially the project that we're working with NASA to do a lot of the development work for this tooling, which sits adjacent to the work that Zeb is going to talk about here in a second. And so okay, I see a question in the Q&A. I think it's more related to data, which is actually probably a good transition to what Zeb is going to talk us through. So let's jump there first, and then if we still need to answer that question, we'll come back to it in a couple minutes. So Zeb, I'll pass it to you.
Yeah. All right. Well, hi, everyone. First of all, thank you for joining us today. I'm really excited to show you what we've been working on kind of under the hood of that application that Anthony just showed you. So again, I'm Zeb. I'm a research software engineer for the Wildfire Tracking Lab at NASA's Goddard Space Flight Center. And we're kind of the team that develops the algorithm and data pipeline that underlies the Fire Event Explorer. So the actual data that are being visualized in this application. So I'll go ahead and just answer this question right off the bat. The data on the Fire Event Explorer is for the current year. We have through the OGC API and other download sources, we have data that goes back to 2012. And that's for the continental US and Canada. So I'm going to get a little bit into the weeds of how we go from nothing to seeing those fire perimeters that Anthony showed you through the Fire Event Explorer tool. So it all starts in space. Anthony, oh yeah, perfect. So we pull from sensors on 3 different satellites, the SMPP, NOAA 20, and NOAA 21 satellites. These are polar orbiting satellites. So about wherever I am on Earth, about every 12 hours, those satellites are going to overpass my location. That's approximately 1:30 p.m. and 1:30 a.m. local time. And we're pulling from the VIIRS sensors on those satellites. So we're getting optical and infrared wavelength. Uh, you can think of it essentially as taking a picture, but it's operating on several different bands or wavelengths. So the pixels in those pictures are about 375 meter resolution nominally, just to give you an idea. So that's much higher resolution than you'll get from geostationary satellites like GOES that are giving you refreshed imagery maybe every 15 minutes. They stay in the same over the same spot on the Earth's surface. In contrast with these polar orbiting ones, uh, we're getting higher resolution, but every 12 hours. And then it's going to be not as sharp as what you might get from something like Landsat or Sentinel, if you're familiar with those products, but those have a much longer time in between revisits. So Anthony, if you hit the next slide for me. So I want to talk a little bit about where we start with the FEDS algorithm, which is what I work on. So in the past, a lot of work has gone into processing the raw data that come in from the VIIRS sensors. So on the left, you can kind of see a figure that my colleague prepared looking at the Creek Fire, which burned back in 2020 in California. And the VIIRS active fire detection algorithm, which is collaboration between NASA and NOAA, goes into that raw imagery and based on physical thresholds, identifies particular pixels that have a high likelihood of active burning. So you can kind of see what that looks like in the left. And also on the left, you can see that this is a satellite product and it can be obscured by things like heavy smoke or clouds. So that's really important to keep in mind as we go in to talk about the potential uses of this data. The team behind this product has put in a lot of work over the years to make it available in ultra real time. So over the continental US, we can get this data as soon as 60 seconds after it's downlinked from the satellite. So that's a product of several years of hard work by the NASA team, and we're really excited about that. And on the right, you can see Firms US Canada, which is a different existing web application that's been around for quite a few years. It's developed in collaboration with NASA and the Forest Service, and it's a really great resource that we know a lot of firefighters and land managers use directly. That one is publicly available. Fire Event Explorer is also publicly available. But if you want to check it out, you can just Google NASA Firms and start playing around. So in this visual, I've set it to show you something like what you would see if you were looking at the latest data from the second day of that creek fire back in 2020. As you can see, this is already a really useful view, but it lacks a bit of the additional context about the evolution of that fire over time that we're able to provide in the Fire Event Explorer. So it's kind of showing you those raw pixels, but it doesn't have any awareness of collating together pixels that are associated with the same fire. So, Anthony, if you would be so kind as to do the next slide for me. So that's where the FEDS algorithm comes in. This is the Fire Event Data Suite algorithm that we've created in collaboration with researchers at the University of California, Irvine, and a few other institutions. So this builds on top of the VIIRS active fire detections, those hot pixels I showed you in the last slide, to track individual fire events. Tracking at an event level allows us to add context about things like the spread rate, daily perimeters, fire intensity, fire line length, persistence of burning, all these different attributes that are really important for scientific analyses that we want to do later on. One of the really cool things about this is that the entire FEDS data processing pipeline is all open source. So everything from the actual code that my team writes, which is available publicly on GitHub, to the code underlying the hybrid cloud data processing system that we use to crunch these numbers, to the database and APIs that make this available to the public, all of that code is on GitHub, which is a really great example of NASA's investments into open source science. A lot of that code is also available to redeploy in to basically has been put out there for reuse by other projects, which is enabling other projects to really leverage NASA's existing investments instead of repeating all that work that's been done. So on the right here, you can kind of see the perimeter progression of that same creek fire. So we're going from those individual pixels, and then what you're seeing here is the inferred perimeter at every 12-hour interval over the course of the entire fire. Next slide, please. Okay, so in this talk, we're going to focus a lot about the software tools that made this work possible. But I want to briefly take a detour into the science side and talk a bit about how the FEDS data and the Fire Event Explorer fit into the informational environment of wildland fire in the US and globally, in case we have people here who are more interested in the fire data than the open source software tools that allow this to happen. So just a little bit of historical context. At NASA and the University of California, Irvine, we originally developed the FEDS methodology for scientific use. There are already a lot of really promising projects working on that. We are doing things like characterizing fire spread, kind of the fire regimes over the continental US and pyrogeography characterization. We're doing things like near real-time smoke modeling, which is being integrated into air quality forecasting and emissions models. We have retrospective studies going on that are helping us understand the drivers of the increasingly extreme fire spread days that firefighters are seeing more and more often on the front lines. We have projects where we're working to use this data to quickly identify areas that are at the risk of catastrophic landslides in the immediate aftermath of a fire, and a bunch more stuff. Um, as a side note, we make this data available also through an API and direct download to researchers. So if you're interested in using this in your research or application, we're going to have contact info at the end. Uh, Please feel free to reach out. We're happy to chat. We provide this data to the public. Uh, Happy to see more uses of it. So, anyways, going back to the kind of context. Um, as we started creating this data and giving it out to our early users, who are mostly agency collaborators or scientists, we were getting a lot of curiosity and interest, and we started providing custom visualizations to the NASA disasters team for use in specific wildfires where the NASA disasters team was being activated. And we started to realize there would be a lot of value in making this data easily accessible to a broader audience, to decision makers, to the public, without having to do things like download like Parquet files and set up your custom environment, load them in, do your own visualizations. So that was a little bit of the seed of the Fire Event Explorer. As we put this out into the world, I want to be clear about what FEDS, this underlying data, is and isn't. So that's my little disclaimer. It's a best effort estimation of the fire affected area based on available satellite data. So this is an area where it could be a mistake to mistake the map for the territory. As I mentioned earlier, like many other methods of wildfire tracking based on remote sensing, feds can be blocked by clouds and heavy smoke. We've also seen like crazy things where superheated smoke plumes will make it appear that burning is occurring outside of the actual fire line. So in the continental US, we have a really well-developed fire management system that responds to large fires with a lot of resources. So if you have an incident management team that's able to produce a high-quality map, maybe using NIROPS aerial overflights, that's going to be higher resolution and more accurate than what we can see for space. This is not a replacement for those maps. Unfortunately, even on the largest incidents in the US, we simply don't have the resources to be flying a plane over every fire every 12 hours. That would just be ludicrously expensive. So FEDS is filling a gap in spatial and temporal coverage, providing decent estimations of perimeters, but at a really nice tempo and for all fires. Particularly in more remote areas, in some cases, this can be the best available information. For example, we have partners in the Brazilian Amazon and really remote areas of boreal Canada who use FEDS-based products to figure out if they even need to go look at smokes that are in super, super remote areas. So in this figure, I'm kind of putting this up to give you a visualization of what this might look like. We're looking here at the comparison between FEDS data, which is these cyan outlines, and the monitoring trends and burn severity dataset called MTBS. MTBS is put together retrospectively after a fire season is over. It uses really high resolution imagery from Landsat to kind of identify burn scars. And so they can get a really nice perimeter of what area actually burned after the fact. And they have analysts who go through and confirm these things. It's a really high quality, high resolution product for large fires in the US. But in some cases, it doesn't come out until like a year after that fire season. So it's not available in near real time, but it's a good reference for us to kind of check as a scorecard. How are we doing? And this shows you nicely, this is 10 years of data. This shows you nicely that FEDS is pretty accurate. It picks up a lot of the burned area that MTBS also picks up. At the same time, there's places that it misses. Those are those red outlines. And so that can happen for a lot of reasons. That can be cloud and smoke cover. It can also be particularly in really light, flashy fuels. If burning is happening entirely in between the overpasses, we can miss a big period of expansion entirely. Uh, Again, we're hitting at that 1:30 a.m. and 1:30 p.m. tempo, which is not exactly ideal for characterizing the diurnal cycle of a fire. As you know, the fire is often going to be a lot more active later in the afternoon and evening as the day heats up than it is at 1:30 p.m., or a.m. So that's kind of my science explanation and disclaimer about what we're looking at here. Now, there's been a lot of work going into this product from a lot of different collaborators. We're really excited about it, and uh, I'd love to take any questions that you guys have. So pop those in the Q&A, and we can talk about any questions about the data now, or we can do those at the end as well. But after this section, Anthony's going to go back to talking about the open source software that supports the database and web application that lets everyone see this data in near real time. That's really the important aspect of this data, is that it's available every 12 hours for all fire detections publicly online. So I'm seeing we've got, yeah, how far back does this data go? That's just, again, current year is on the Fire Event Explorer. And then if you go to the Wildfire Tracking Lab's webpage, we have an API that makes data available back from 2012 to present. Cool. All right. I'll throw it back over to you, Anthony.
Yeah, that sounds good. I haven't seen any new questions come in. But again, if you have them, throw them in, and we'll have some time at the end to answer those questions as well. But I'm going to talk a little bit, like Zeb mentioned, about the software that's powering the Fire Event Explorer, and also just a larger ecosystem of open source tooling that this lives within. So I mentioned the VEDA project earlier, stands for Visualization, Exploration, and Data Analysis, because we all love an acronym, and it's a pretty broad-reaching project. It started in about 2022, and one of the initial goals was that we wanted to support and encourage NASA's transition to the cloud with the Earth science data. And one of the ways that we intended to do this was by showing the power of analysis-ready, cloud-optimized data. And that takes a lot of different forms. So anything from giving cloud compute environments for scientists to perform true data analysis, all the way to highly curated narratives that we can publish as like New York Times style articles that use Earth science data. So we wanted to be able to show that there's all these different modes of interacting with cloud hosted data, where we don't have to duplicate the data and store it in multiple different locations. If it's in the cloud, then we can build all these different tools off of it. That was the initial goal of the VEDA project, and it's largely held true. I think it's now evolved to where it's not just about Earth science data anymore. It's really anything that's geospatial in nature, and the different tools and widgets that we've been developing throughout time have continued to evolve. But one of the initial guiding principles was that it's all open source. And so we wanted to build off of existing standards or tools and libraries that the open source community had been building for a long time, as opposed to reinventing the wheel and trying to build from scratch. So this is just an example of a few of the libraries and standards that we utilize. So especially in the services underneath these tools in the Fire Event Explorer, we see a lot of we see EO API, which is heavily used as a way to process and provide access to this data, but it's all using stack standards and OGC APIs as well. And so just to give you a visual of the complexity of this ecosystem that we've constructed. And in particular for EO API, I would say if you're interested and have similar needs with large cloud hosted sets of data that you want to provide access to either programmatically or to be able to build custom tools on top, I would go to this website, eoapi.dev. It's a great resource with a ton of documentation that links out to all these different community tools. One library in particular that was especially important for the Fire Event Explorer is called TyPG. And this is really a complete backend and service architecture. And what it does is any geometry stored in a TypePG Postgres database can be accessed with either a Features API or a Tiles API. And both of these were used pretty heavily in the Fire Event Explorer. And this is a really cool library because all this comes out of the box. So as long as you have a little bit of experience writing Python, or your AI tool has experience writing Python, maybe, you get this Features API and Tiles API out of the box. And that enables you to build custom tools like the Fire Event Explorer on top of it. So we wanted to call this one out specifically as something you might find value in and want to look into. More on the front end side, we've been developing a number of capabilities to communicate Earth science data in the browser. And I want to highlight a few different categories here. The first being websites and catalogs. Again, we're building this set of capabilities for Earth science teams who want to communicate their data. And what we find is a lot of scientists want to go to a conference and just send a link. They need a web presence. They want to send a link to whoever they've just met to say, go here and read about all the work that we're doing. And so that's our starting point for some of these tools, because WordPress and Wix and all these different website builders, they don't handle geospatial data very well at all. And we wanted to provide an open source option for that to happen. From there, that's where we provide access to these different tools. So the Fire Event Explorer lives within one of these websites that we've built, in particular underneath this Veda dashboard. And we've built a number, I want to say 10 or 15 custom tools. The reason that we have been focusing on so many different tools is because we know that one of the main value add that these science teams bring to the table is they bring in a data product, right? There's a new data product in the world that tells a story, helps us understand our Earth a little bit better and make decisions. And often that new data product has really custom visualization needs. And so that brings a custom tool. And so the Fire Event Explorer is a really great example of that, where we're able to show fire progression data in a way that some out of the box standard GIS tool probably wouldn't be able to show. And then to go even a step further, we have these narratives and these like New York Times style articles that allow scientists to have a highly curated explanation of what their data is, what it shows, maybe a really unique insight that they have themselves pulled from that data. And it just really helps people connect the dots. So instead of just sending a link to an API, you're able to send a link to a tool that is custom built for your data, and also maybe some narratives that give a plain language explanation of what people can find in that data. Well, let's dive a little bit deeper into one part of the tool that we built, because I think it will help show some of the reusability of these open source tools that we built. And I mentioned this in the demo, but vector visualization using weather data. Now in the Fire Event Explorer, like I said, we're using NOAA's data here, and we're trying to show wind speed and direction. The cool part of how we built that, though, is it can really be reused with any weather data. As long as you know the layer, which is its own challenge, as long as you know the layer from NOAA's HRR data or ECMWF data, or any of these large weather data sets, you can follow a similar process and get these sort of vector visualizations into your tool. And so György Malewski, who's the developer who led the development effort on this, posted a really nice explanation and walkthrough of how to do this. We'll share these slides after the fact, so you'll have this link if you're not able to get it down now. But in summary, it's pretty simple. There's 3 short steps. You know, 1, you need to access the data, and again, you need to know which layer you're accessing. And so for many of these data, there's already They're already hosted in the cloud. There's already really mature APIs behind them. But then you can use VSCI curl and T-Tiler, which is one of those open source libraries that I mentioned earlier, to extract the wind bands and then just render the result on the map. And in this case, we used DeckGL to build our tool, which made it really easy to render these vector visualizations. So I wanted to highlight this because one, I think is really cool. Two, it's a really good example of where we built not just a tool that can be embedded into other websites, but we have this component level, very like open source, reusable piece of code that can be a blueprint for other teams who are building tools. That can be a blueprint for anyone who wants to overlay this type of information in their own map. So speaking to that blueprint a little bit more, I want to zoom now back out to talk about what we just saw, because this Fire Event Explorer, I think we give the demo and it looks great, but I just want to take a moment to appreciate all of the different pieces that have been being built over the last 10 plus years, I would say at least, to result in this Fire Event Explorer. So Zeb talked a lot about the data, and if you remember, he showed this diagram of all the different logos and pieces of the puzzle that had to come together to result in the Fed's data in the Fire Event Explorer. That is a whole very complex world that I know from my perspective, I'm super appreciative that NASA and NOAA and the US government has been investing in these open data programs for so long. But all that data is totally open and makes it easy to access and build tools. I mentioned TypePG as an open source Python package. It's utilizing open standards that have been developed by the community over a long time. The tools that were built, even the Fire Event Explorer itself, uses US Web Design System, which is an open design library. And the tool itself is totally open source code. It's published to NPM. So any developer out there building their own website can pull in this tool themselves if they would like to use the whole tool itself. And then the websites are totally open. So I mentioned, we have these different websites and dashboards that we've built under the beta project, but we've provided a template dashboard that's totally open source that gives teams a starting point if you have geospatial data or earth science data and you want a web presence for it. And so I just wanted to share this just to take a step back and have a moment of appreciation for the entire open source community and all the work that went in to come to this one tool and data product. Okay, I'm seeing some questions come in. And so I think it's a good moment to go to the Q&A. I'll drop on this slide just so y'all can see contact information if you would like. But let me start going through some of these questions here. I see a couple of questions on the data. So Zeb, if you want to jump in, the data gained from MTBS tracker using Landsat to train models that can more accurately reflect. I think you probably have some interesting insight into that.
Yeah, so I see a couple of great questions in the chat. I'm going to kind of start going through chronologically. So Nelly asks, is data that is gained from the MTBS tracker using Landsat used to train models that can more accurately reflect actual fire perimeters more accurately over time? So it's a great question, and it gets at one of the key features of the Fed's data compared to like kind of the current state of the art. So the MTBS, which is that reference data set, monitoring trends in burn severity that I referenced on my last slide, is put together using high resolution Landsat imagery. And so the way that they actually do that is looking at Landsat imagery from before the fire and fully after the fire. And then they're able to look at something called the difference to normalized burn ratio, or DNBR, and outline the areas that the impacted vegetation and soil reflectance shows have been burned. The key point there is that you can only get the final burned area from that because Landsat has a much greater interval in between revisit times. So it's not the most useful for training models that can understand fire progression over the lifetime of the fire as that's moving. For that, you need a shorter revisit interval. So we use the VIIRS sensors for that because we get that information every 12 hours. Potentially the Fed's data could be used to train models that can more accurately reflect those actual fire perimeters over time. That would be a great avenue for further work. Um, that seems related to the next question from Hilly. Thank you. It's in what context is the information most useful? Can it be used for evacuation or is it not ideal for that? You mentioned landslides awareness. I guess what I mean is the data most useful for future planning or can it be used in real time? This is also a good question. I'm going to answer both most concisely and then I'll explain. Uh, I see two big avenues for value out of this data. One of them is retrospective scientific studies. So this was originally developed to push forward our understanding of fire behavior based on scientific studies that are typically happening after a fire season has ended or after a fire. So having this 12-hourly progression of fire perimeters allows us to study things like fire spread in a new way uh, that can eventually, our hope is it will feed back into both improving fire modeling tools that are used in real time and additionally improving things like fire policy and land use management. That's kind of one half of the answer. I think the other half, and this is something that we're a lot earlier in working out, is that kind of real-time usage. So one way, as you said, that this is used could be useful is a landslide awareness. So there are these Bayer teams that go out immediately after a fire to stabilize impacted areas and make sure that communities nearby are safe. Uh, the current product they use is not, we can't generate that as quickly to kind of like make maps of like the riskiest areas. But we have actually a paper coming out by Elijah Orland in the next month or so explores the Fed's data can be used to create a real-time estimate or metric around that. Um, in terms of if it can be used for evacuation, that's a trickier one. Ultimately, that decision needs to go through the incident management team that's managing the fire. This could become one data point in what they use. Uh, on the other hand, firefighters on the ground might have more accurate and timely information about a specific fire. So answer is both. I hope that's helpful. I'm looking at another good question from Nelly, which asks, with such a high temporal resolution, is this tool already being used as a mechanism to assist fire dispatching to sites? And yeah, we are back in PL4 after a few sweet days at preparedness level 3. Things have bumped back up nationally. Um, I think that's another place where this could be one piece of the puzzle, one screen that people look at to kind of help with their situational awareness. Uh, a lot of that value honestly already comes from firms, I would say. So that's another one where it kind of comes back to the like NIFC and their situation awareness and the GACs to kind of um, assess all of the sources of information at their disposal, which are quite a lot, and then make decisions about preparedness, dispatching, resource pre-positioning, that kind of thing. Okay, and then how can this data be used to model fire activity and modeling? Currently, there's research using terrestrial LiDAR to obtain information on field typing at the ground level. Considering that feds may offer useful variables using NOAA data, have any of these variables been used in regression modeling to predict potential outcomes? One thing I'll kind of mention is that the Fire Event Explorer, this web application that we showed, pulls in NOAA's HER wind data. That is not a part that the Wildfire Tracking Lab is producing. That's a separate product that could be really useful to look at in conjunction with our fire spread data. But that's something that comes out of NOAA. That being said, I personally think there's a lot of really interesting work to be done using this data. So if you're a researcher who would like to be able to use 12 hourly fire perimeters with associated detections that include things like fire radiative power, fire line spread direction, fire intensity, fire line length. Um, that's somewhere where this data can really feed into understanding that better. Uh, we don't include any information in our data set about fuel types, but that can be a really interesting input to further studies where you can look at, okay, if we combine fuel type, say like land fire, fuel classes or whatever, can we look at how fires progress differently through different fuels in kind of a systematic way that we haven't been able to before? So yeah, some great questions. Thank you guys.
I don't know if you guys saw, there was also one that ended up in the chat asking, let's see, currently working on a small project focusing on wildfire tracking using thermal infrared imageries. My plan is to process these imageries at intervals over time, factor in elements such as wind speed, wind direction, land vegetation type, and grass species, then convert radiant values to Kelvin temperature so I can use interpolation to trace the fire perimeter and potentially predict its spread. So the question is, if you have any additional suggestions for factors they should consider, and love to hear your insights or tips, or experience on that.
Yeah, that's a great question. I think a lot depends on the source of that imagery that you're getting and the data you have. I'd encourage you to reach out via email if you're interested in continuing that discussion. Also, Yang Chen's paper from 2022 is another great place to start. I can drop the title of that in the chat in a second.
Awesome. All right. I'm not seeing any more questions in the Q&A, but if you all have some and you want to pop them into the Q&A, we can do that. Seb and Anthony, do you have any last minute words you want to share? I mean, this has been truly an amazing project that you guys are working on. You know, everything from landslides, forecasting smoke spread. This is just pretty cool, all the work you're doing with open source and NASA. So really appreciate you guys coming today and sharing this with everyone. And again, so I shut up. Do you have any last minute words you wanted to share with the attendees today? Are you good?
Yeah, I
Anthony?
would just say like I really appreciate everyone showing up. I think the work that Zev and his team are doing here, like Jamie said, is super interesting, super important. And I just appreciate the interest and would reiterate that if there's anything that piqued your interest in the presentation, please reach out, even if it's just to connect. I think the more we talk and the more we connect, coming from someone who works in the open source community, maybe this is the ethos, but I think the better off we'll be. So I just look forward to hearing from you all.
Yep, totally agree. Kind of same sentiment here. We're really looking forward to moving forward open source science and, uh, you know, putting everything we have in service of working on the increasing challenges of wildland fire management, which is only becoming a more and more serious issue. So yeah, thank you all so much for your interest today and for being here. I'm also open to follow up offline if you'd like to keep talking.
Awesome. Awesome. Thanks so much. And before we close out, I have a few things I want to share with everybody. Just some real quick stuff before we let our guests go about their day. But I just want to share a few things about the Geospatial Professional Network. And thank you guys for attending this webinar. This is one in a series that we put on. Our Climate and Community Resilience Committee puts on a number of these wonderful webinars. Please feel free to reach out if you have suggestions for future ones, but keep an eye on our LinkedIn page and so forth for future ones. Other upcoming events we have coming, if I can get to my next slide here. So if you're need some leadership experience, our leadership academies are award-winning. Leadership academies, we have a virtual one coming up on October, our advanced one in November in Louisiana, and then again in December. The the traditional GIS Leadership Academy. Other programs, if you're in California, check out CalGIS, or you don't have to be in California to go to that. And a great event. The LEAP conference will be happening in March, and the ValTech conference at the end of March, early April. And this webinar, as an attendee, you all will receive a link for the recording to it. The recording, this and other webinars and additional learning resources are available on our new learning annex. So you can check it out here on our new website. And upcoming, next, very exciting, is the annual GIS Pro in the Rockies conference in 2025. It will be in Denver, and hopefully I will get to see a lot of you there. It's a great program, a great lineup. Check out the GPN website to get more information on GIS Pro and all the other programs that we have to offer. And so with that, I do again want to thank our amazing presenters today for coming, and thank you all of you attendees for showing up. And again, all these resources, amazing resources that they provided, will be sent out to attendees later. So thank you all for joining us today, and go out and have a great mappy day. Had to end it with a corny thing.